Welcome everyone, and thank you for joining us for today's panelist discussion, where DefMethod's very talented engineers will be breaking down test-driven development, also known as TDD. My name is Jennifer Imamura. I am the Director of Business Development here at DefMethod, and I'd like to take a moment just to tell you a little bit about who we are. DefMethod is a New York City DefMethod is a New York City-based custom software consultancy. We follow highly strategic and successful methodologies, including Agile and today's topic, TDD. We truly pride ourselves on our flexibility and open, transparent processes, and we're committed to keeping projects simple yet very efficient. Our dedicated team of software engineers and product managers deliver very high quality technical solutions through passion, extensive knowledge, and their expertise. And we've seen that consistently drive successful results with all of our clients. Here at DefMethod, we truly believe in providing quality code and in continuous learning so that we're always the best for our clients. I welcome you to check us out at defmethod.com. Learn more about who we are as a company and any of our panelists that will be speaking today, as well as all the services that we offer. At the end of today's event, I'll have a few additional announcements, including current job openings. Yes, we're hiring, so stay tuned to the very end. But without further ado, I'll pass it over to Yisselda Rhoc, today's moderator for our panelist discussion.
Thank you, Jen. So yes, thank you everybody for attending. We are spending the next hour with us. We're going to talk about the software development process, that is test-driven development. We'll refer to it also as TDD. It's a practice that we've used and have seen positive impacts on our work here at DefMethod. If you have any question while watching the panel, feel free to send a message or your question to through the chat to DefMethod. We will address your questions on the fly if we can, and if we cannot, we will have a dedicated Q&A portion to answer your questions. Kristen is moderating, so you'll have somebody receiving the questions as you go. I'll ask all of you to hide your video and mute yourselves so that we can keep the panelists in the spotlight view. Yeah, so let's start with introductions. I'll start introducing myself. So hi, my name is Yisselda Rhoc. I'm a software engineer, senior software engineer at DefMethod. I've been developing professionally for over 5 years. And when I started professionally, the first project I was on was a legacy 8-year-old app that had no unit tests. I remember looking through the project and there was only the generated sample test targets, and my manager did not see why they should be unit tested. All that has changed a lot since I joined DefMethod. And I'll let our next panelists present themselves. Jeff?
Hi, I'm Jeff Gia. I'm a principal engineer here with DefMethod. I've been developing software for about 14 years and also writing unit tests and practicing test-driven development for 14 years. So subsequently, I have lots of opinions and a lot of words to say about that, which is, I'm guessing, why they asked me to be part of this panel.
Thank you. Mark, can you go next?
Yeah, hello, my name is Mark Simpson. I'm a senior software engineer here at DefMethod. I've been a software engineer for a few decades on various systems, platforms, languages, etc. I've been doing automated testing of various levels through a lot of that time, and especially in the last 2 decades, TDD has been an important tool that I've used. That's me.
Thank you. Can you go next, Keith?
Howdy, I'm Keith-Perfetti. I'm also a senior software engineer with DefMethod. I've working with Def Method for like 4 or 5 years now, and I've been a developer for about 8, 9, which makes me feel old. Not as old as Mark, but he was at the original Walden cabin. So yeah, my first project I ever built was in ActionScript, and I also had to build automated testing for it because you can only play a Flash game so many times before you don't want to play it anymore.
Thank you, Keith. So first, to kick off, we are going to go through a definition of what TDD is. So Jeff, could you tell us a bit more about this practice?
Yeah, test-driven development or test-driven design and development, depending on how you want to split up that acronym, is just that, the practice of writing what you expect an application or piece of software to do before you actually go and implement any lines of that software. Yeah, and then continually running those automated tests against your code base to continually confirm on a daily basis that, hey, everything continues to work the way that you expect it to work, and that you've defined it to work.
Thank you. Can somebody talk about the importance of unit testing and integration tests and the feedback loop that you get while TDDing? Mark, for example.
Sure. Yeah, I'll jump in. Unit tests versus integration tests, and specifically the feedback loop, is a good question. Unit tests are usually very fast and very small, so you get a very good feedback loop. You can run them many, many times every time you touch code. Whereas integration tests will tend to be slower because they're talking to a database. They might need more setup. They'll take more time. So they'll be run in a slower cadence. I think on a day-to-day basis, I prefer unit tests, although some integration tests are useful to make sure other things are still working, since unit tests are pretty isolated. Did that answer the question? I think it did.
I think just to add on to that, integration tests also help you realize when your class's API might not be as efficient as you want, because you'll realize that, like, spending all of this time doing test setup, I have to do all of these things in order to like make these two things work together. And I usually find that when my tests are super hard to write, I'm just doing it the wrong way. And integration tests kind of help you like vet that you're actually making something easy to use versus just making a thing.
And the other thing I think that separates them more is unit tests tend to cover, at least in my mind, more of the design and driving of your application, whereas integration tests you tend to not be able to necessarily do until after the fact to make sure nothing moves after you've already laid it down. Integration tests are kind of like taping it down so the wind doesn't blow it away.
Yeah, so what are some common mistakes that beginners make when starting test driving their code? Keith.
I think a mistake a lot of people make is starting to just write code and then they add a test and then they start adding more tests after that, because it gets you into a somewhat bad habit of like, sometimes part of it's not test driven, and that's going to lead you down like a slippery slope, because all of a sudden you'll start writing bigger and bigger things. So it feels really pedantic to be like, I want this to do this exact thing and only solve for that. And it feels really weird, especially at first, because you're just like, but this would be so much faster. Why do I have to write this mock-up to show that 2 + 2 = 4? But you know, when you forget to do it for a day and then you come back the next day, that code that you wrote the day before, you're not going to remember exactly why you wrote every part of it. And I think I think that's like the main thing that gets people. And then the other part is just setting up tests is sometimes kind of hard. I think when you're just starting, it's easier to pull in a project that already has tests built, whether that's like an open source project or, you know, just anything you can find online. And then using those tests as a basis to write more tests is going to be, it's going to speed up your ability to acquire test-driven development because you're going to already have the patterns there. Because, you know, personally, even when I start a new project and I start to test drive things, I'm like, okay, what were all of the test things I have to do for this testing? Because, you know, we have like Mocha, we have Jasmine, we have RSpec, we have, you know, there's like a million testing frameworks out there. They all have slightly different syntax. It's nice to be able to look up in the project you're working on, okay, these are how these tests work. I'll follow that pattern. It's starting from scratch, you know, kind of hard.
Mm-hmm. So your advice would be to not start from scratch and start looking at a previous project that already has tests set up?
Yeah, that, or if you have like a friend who's good at, you know, writing tests, pair with them. And that way you want to take like the cognitive load of having to know the new syntax off of you. That way you can focus on how does testing really work? Because, you know, with programming, there's always like, I want to learn this new thing, but I also have to learn the new syntax of that thing. And if you can make one of those burdens lighter, it makes it a lot easier to internalize, okay, let's do the testing. And it gives you a little bit more confidence than, you know, stumbling around in the dark and then being like, okay, that test works, but like, why does that test work?
If I could jump in, Yisselda, you asked what new people to TDD, the mistakes they make, but a mistake I see in people and also people who've been doing it a while make related to what Keith just said. If a test fails, often a person won't look to see if they understand why it failed. Is it failing for what they think is happening? Or in the opposite case, is it passing for the reason they think it's passing? And so you can make an assumption and go down a rabbit hole of work thinking, oh, well, why is my code not working? When in fact the test itself might be broken. And it comes back to the idea of why are we doing this testing? Why are we writing the test especially first? Is to make a statement saying, I plan on doing X, and here's something that will back that up. And then you do X and see, did it match? Whereas if you say, I mean to do X in a test, but didn't actually test for that, then you can do lots of stuff and never get that test to pass, or vice versa. You can have a test that passes and never fails, which is why I say never trust a test you've never seen fail.
Mm-hmm. Definitely. Well, that's kind of what you have. Like one of the definitions that you see around is like the red-green refactor loop.
Mm-hmm.
And so, yeah, I don't trust a test that does not fail. I'm always suspicious.
And it's important to take small steps there, like write just a little bit of a test. I will even sometimes be very pedantic about it. I will write really a tiny bit of test. If it doesn't compile, that's failing. And then I'll write a little bit more and I keep going back and forth until I get a test that passes, then I can try a refactor, etc. Taking large steps, like Keith was saying at the beginning, it can lead you to bad habits in general, but also it can get you into trouble when you're trying to do something new like TDD.
Mm-hmm. Yes, like a bad habit I had when I started out was kind of having a checklist of tests. So all like 10 tests that fail, and then trying to make them pass as I go, almost all at once.
I find that the tests for me help me focus on doing one thing, which is the best for my brain.
Yeah, I also think that sort of pattern helps with realizing when you'll need like a service object or to pull some sort of logic out, because you'll realize, okay, I'm setting up or I'm getting ready to test all of these things, and you're like, but does any of that have anything to do with the class I'm actually working in? Especially if you're doing some sort of like MVC controller stuff. Sometimes that stuff gets like really out of hand. And all of a sudden you realize, like, I have this gigantic test that's testing all of these things, and like, you know, it's now too complicated. Like the test itself is too complicated to understand, so much less the code that it's testing. So I think, yeah, being able to focus on, like, you know, this part does this thing, this saves these attributes, versus like, well, it receives these parameters, which then transforms, which then, you know, if you can break it down small enough for tests, it's going to be able to be picked apart and refactored when it needs to be, because no software is ever going to stay the same forever. It should.
So yeah, I had I had a question that we got from our engineers, were like, which pitfalls do you avoid when you test drive and test instead of writing your test afterwards?
I think that's you guys have covered that a lot. Is what it really illustrates to you is kind of creeping complexity. As if your tests are hard to write and maintain, the code is probably also hard to write and maintain at that point. Usually the more setup that is starting to happen for a test, usually that's where refactors and stuff happen, and you get into a little more of kind of interaction testing rather than completely functional kind of testing at that point, where you just say, okay, let's break all of the actual work and logic down into very little pieces and just make sure this one big thing does these pieces in the correct order. And what that tends to drive down is your software's psychometric complexity. Like usually you will only have in each class a single for loop if you're doing your testing well, because setting up nested for loop testing is a nightmare of setting up a bunch of nested lists you know, most of the time. So you kind of just say, okay, it goes through this, and then it talks to this other thing, and that other thing does its thing. And then in the other thing, you have, you know, its test of like each one of these things does its thing. And if you want to break it down even further, you say, oh, you know, when you're given one of these things, it does this. And that tends to happen more often when you try to test drive it than when you don't. It's easy to kind of write big if-else statements when you don't have to set up an equal number of tests to run through those big if-else statements.
Yeah, definitely. So for new and small projects and proof of concepts, is it important to use TDD? To use TDD like for proof of concepts and small projects that might change very quickly or evolve or are throwaways, basically? So
I will say this: if you absolutely 100% trust your product or project manager that you will be allowed to throw all your code away and start over from scratch, and they will not give you any hard time about that, I say go ahead. The pithy answer I usually give to what code needs to be test driven and tested is code that you want to work. And now that as you were saying, there are other reasons to write code. If the code is there to make a proof of concept, and the proof of concept doesn't necessarily need to work, but it needs to secure funding, that is a different world than if it's a piece of code that needs to work. But I would, you know, challenge pretty much anybody who's done software development for any significant amount of time not to have a story about the throwaway code that becomes the heart of their system at some point. So that might be an exercise in paranoia or lack of trust, but to me, every time I've heard this is a proof of concept, I will have to ask the question at least once a week to say, and when it's over, we are starting this project over again and we are throwing all this away, right? And even then, even when they say yes every time, I'm still not necessarily convinced.
Yeah, definitely. Like, how would you advocate for, because often it's a question of speed. I find that this comes up like, oh, let's cut on something. So how would you advocate for TDD when there's also like this need for speed?
I mean, it's just adding technical debt if you don't write the tests. Like, you can do whatever you want in an app, right? But if you don't have tests, it just means, unless you have a wildly simple application, like you're the Jeff Bezos of to-do apps, like your application's gonna be complicated. It's gonna start having edge cases. It's like you're just gonna find things. And if you haven't encapsulated the logic, I can't say how many projects I've worked on where there's no testing around one small part. And then one company I worked for, I asked why we didn't have any testing around, revenue calculation. And they asked me why. And I said, well, we have 6 different definitions of revenue. And I was just in a meeting where all 6 teams who use a different version of revenue were arguing with each other about what the actual revenue was. And it's just, if you don't test now, you're just going to wind up with parts of the app that nobody understands later. And somebody gets hit by a bus.
The way I like to, the way I like to present this is, when people talk about it as a way to speed up the development of an application, I kind of liken it to building a house. Like, you have, when you're building a house, you're going to have measuring, you're going to have cutting, you're going to have hammering, you're going to have painting. If you want to speed up building a house, you build a smaller house. You don't say, hey, build this house, but don't do any hammering as part of building this house because we need to save time. That's what I see as test-driven development isn't a living room or an extra bathroom that you put on or take away. Test-driven, if you're doing test-driven development, it is the measuring or it is the sawing before the hammering when it comes down to it.
And I just wanted to add about, it's almost a false dichotomy, if I've got the wording right, that if you don't do TDD, even on these quote unquote throwaway things, which of course never get thrown away, you still have to test them. Yeah, sure, you might not have a TDD. Maybe you'll have tests after automated tests, maybe you'll have integration tests. But a lot of times when I've heard the argument of like, let's skip testing to get this proof of concept out fast, the people aren't factoring in that testing takes time and testing needs to get done. Can you launch the app, look at the browser, click through it a few times to test everything every time you touch the code? That's very slow. But I can write that sort of test as a unit test and get confident enough that, yes, when I, every hour or so when I'm taking a coffee break, I'll do the quick click through the test and double check. That's my manual integration test. So skipping the TDD doesn't necessarily buy you time. It changes the location of the time the testing takes. And I think quick automated unit tests actually are faster than the equivalent manual testing or integration testing, et cetera, later on in the cycle.
Definitely, I feel like in the end, it takes more time when it's your users finding testing,
yeah.
basically.
Yeah. If your users are your testers, then don't do that.
We had a question from Tusif Murtaza saying, so regarding using TDD for proof of concept, but not for proof of concept. So for larger and running projects, what do you suggest to choose TDD over BDD when we have limited time to build and deploy a feature.
Did you say BDD as in?
BDD, behavioral, I guess.
Yeah, yeah, exactly. There is something called DDD, which is a different thing. Huh, interesting. And I guess since I started talking, I'm going to be answering this one. Crap.
Yes.
So my experience with BDD is probably a little tainted from the way I came about it. So I'm not sure if I'm talking about it quite by the book. But I know it came about from a group that wanted to interact with the customers a lot and get the customers to help write the tests. The customers, sorry, let's use the word user. Customers maybe more of an extreme programming term. So you'd work with that user or PM in some projects to help write the tests, and the test would be written in sort of a vaguely human language, often with the given blah, 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 then when blah, 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 expect blah, blah. And then you could automate that semi-human language. And that's how I understand BDD. And I think it's really a great idea. I have sadly never been on a project where I've gotten that much customer interaction who actually wanted to help me write those tests. It was sometimes was useful for me to use that terminology to gather the information about corner cases from them. And then I would just go write that as a JUnit, let's say, style, or our other testing framework style tests, where it's just written straight into code and not through some sort of intermediate humanish language, like what is it, Cucumber?
Gherkin? Yeah.
Gherkin is Gherkin is the common standard for these BDD tests. However, I think I might be missing a little detail about what BDD is intended for, so I apologize. Again, this is from my history of how I came into it. Anybody else have anything you want to add?
I think you've gotten most of it as far as my interaction with it as well. What I find it is great for is extracting it away to the parts that should actually matter to your software, which is, does it work for a person if a person were to come and use it? What I think it misses is some of the other benefits of TDD. It kind of feels, once again, like kind of a supplementary to all these other things, because the other things that you lose is kind of the stuff that doesn't surface, things that shouldn't surface, and how those things are, how you protect people from scenarios and things like that that shouldn't surface, like exception handling and those kinds of things. The things that should be buried from the user, their test-driven or their BDD scenarios are just like, hey, the user does this weird thing and it triggers this thing and nothing happens. Like, you don't see it, you're testing the negative, right? Like that they don't have this experience, which you don't quite catch the nuance and the documentation, which is another big usage of, or big benefit from test-driven development, is you kind of document the choices that are going into your code behind the scenes of like, okay, this is how I've decided this exception handling should work. And yeah, just kind of the little nitty gritty of it. BDD is great to kind of put a big overarching framework of, hey, once I'm finished with this feature, this is how it should work. But all the nuts and bolts aren't quite there when you don't weigh your gears, you know. you make sure everything in the engine is running smoothly at the end, but you're not weighing your ball bearings as you're putting them in.
Yeah, I feel like BDD, because I've used that approach with PMs, that's more for integration tests. Then, like you said, like the nitty-gritty and documenting for software developers, whereas BDD will document more for, like, it's more contracts with you and your product owners.
I think if the question is, should I use BDD or TDD, the answer is yes.
So the answer is yes. I'm looking for the questions to see if there are any relevant for us right now, but I think we'll come back to those in 10-15 minutes when we do the Q&A. So regarding, I'm going to jump to legacy code because I've seen some questions also in the chat about that. So Mark, how would you, how should engineers approach TDD when they are working on a pretty untested monolith?
Very, very carefully is the only correct answer. But to get a little bit more detail, so when you've got a lot of code that doesn't have a lot of tests, hopefully they at least have a manual test plan that someone has to run through. But you have to you have to get some idea of what is it supposed to do, and then if you want to modify one part of it, you can take two ways. You can either literally just come up with a manual test that will make sure you exercise that chunk of code, and then use that as your test loop, which is very slow, but I've done it. Sometimes it's necessary. So you test that it does a thing, you modify code, you test if it works or changes the behavior. That's your test loop, very slow. But that might be one way of attacking it. It's not TD, I apologize for not answering the question quite. But you can start to automate parts of that, and maybe you write a sort of a big integration test that might take a minute to run because it has to set up a database. But now you've got some sort of security. You have to have this testing security blanket to help you make sure you're not breaking things. And then what I find the best case is once you've got that some way of assuring yourself that I'm not breaking something, you extract the part of the code that you want to touch. You use refactoring in the purest sense. You pull out a new class, a new function, you pass in all the parameters it might need, even if it looks crazy with 12 things. And now you've got that separate. And now you've done that, you stop, you make sure your tests all pass, you commit the code, and then you can look at this code you just extracted and write some tests around it, because hopefully it's a small chunk. You can start refactoring it to move dependencies outward, like it talks to a database directly. Well, have it pass in a database connection, all this stuff. But you have to do this very carefully. It takes time. It is not a fast process. But now that you've got a chunk here and you've tested it, now you haven't yet made any changes that you want to make. Now you want to make a change to this code. Now you want to change its behavior. Now write your test that proves it changes its behavior. That could be modifying an existing test that you already wrote to say it does X and now you want it to do Y, or you say I want it to do X and Y, and now you change the test. So there's to work in legacy code or code with less testing than you would like, you have to take it very slowly and carefully. One, I want to give a plug to a book, Working Effectively with Legacy Code by Michael Feathers. It is a very good book about how to deal with legacy code. That's where I got this general game plan of mine. He talks about finding the seams in the code, like if there's a class boundary or a function boundary, because then you can extract that out so that you can then work on it separately and more carefully. And that's why I was saying you write manual tests, you write integration tests. So finally you can extract out a section, and now this is insulated from the rest of the untested code. Mm-hmm. And you can, as he puts it, you have a little pool of pureness, of testability, surrounded by the untestable marshlands and swamp. And then you can start pulling stuff out and start to purify stuff and make it better. You don't need to do it all at once. That's a good way of annoying all your managers, because it will take a lot of time. But you can get stuff under some sort of control, even if it's not technically TDD, unit testing, still automate it, still write down the steps, still take careful, slow progress.
Yeah. A slight variation on that, I think, and I'm sure people out there, if they've been working for any amount of time, have heard the term strangler pattern. It's kind of the opposite of that, where the legacy code becomes kind of it becomes the deep well or the hole in the ground that you put a fence around, and you'll not necessarily touch or modify it unless it's completely necessary. It becomes the black box API where occasionally you'll have to go and spelunk in and bring out the, the deep dark treasures so you can actually modify them. But what you build is your strangler vine around it of everything outside of it is test driven in your creation, and whatever is legacy is just what you interact with when you have to. And as more things get changed about that, those functionalities get moved out into the strangling pattern so that the legacy core code gets smaller and smaller. It's kind of the same theme, just kind of the opposite, from the opposite direction. You build outside first and start to grow inward as you go, versus you kind of scaffold a little bit on the inside so you can bring it out.
Yeah, I think that kind of, there was another question that I think is related, is about test coverage. So like how much test coverage you should have, how many times, are you testing like too many times the same thing? Do you have any opinion about that?
I would say with test coverage, one of the things I think of as testing too many things is if I have a test and it includes any logic from literally any other class, unless I'm doing an integration test between those two specific classes, you gotta mock out that other class's behavior, because otherwise now you've introduced, now you're just testing more things in one file than you should be, which is just gonna drive you nuts later when you can't figure out why this thing over here fails. Whereas I think if you're TDDing, you should be testing that the function that you are currently writing does the things in the TDD. If there's like a private method that formats stuff internally, don't test that. It's a private method.
Well, you test it from your tests, probably.
Right.
Yeah, like your test itself should be checking for that thing. But you should only, I feel like you should really only be testing the public interface. And you should only be testing the public interface that you are actually building at that moment. Because, for example, in Rails, if you test that, your active record request is pulling the right things, well, you're actually just testing active record as well. And that's not as useful as being like, hey, does this thing give me the things I want if I feed it these things?
Yeah, with any like kind of summary number, like code coverage is sometimes it's like, it's nice and it can be useful if you need a kind of quick digestible way of looking at something of how I'm doing. But yeah, it's kind of just trying to assign not an arbitrary number, but a number that people put a little too much weight on to something that should probably be kind of, you should probably be able to get a daily kind of just litmus, dip a toe in kind of thing of how my tests are doing. So yeah, I think code coverage strive for the number to be high, but if that, you can get code coverage with tests that don't have assertions in them, honestly, when it comes down to it. Like, it just tests how much of your, how many of your lines of code are being run, not necessarily whether your tests are good. So
I think that's the very most important thing to keep in mind, is that the code coverage tools, from the ones I've seen, are useful for figuring out, like, how do I have a hole in my test? Like, oh, nothing I ran my test ever executed this line of code. But it doesn't actually tell you that you've tested anything. It only tells you if you have executed the instructions that that line of code represents or gets compiled to, which is good to know. If you run your entire test suite and you find out that there is a class that has zero coverage, then maybe you want to look at that. But on the other side, yes, you want the number to be higher. Higher is good. But 100%, I used to be in the I have to have 100% coverage camp to try to get people to do it. But the trouble is, it's very easy to game because, again, you're not checking that you're testing things. You're just checking that you executed things. So it's very easy. It's actually not too hard to get 100% coverage on lots and lots of stuff. It doesn't tell you that you've actually tested anything. So yeah, coverage is a useful tool, but keep in mind what it is and what it is not.
And there's some stuff out there that can kind of help drive the quality of the test out that rather than the quantity. But those I have not had too much opportunity to play with on a large scale, like professional basis, like not chaos testing, mutation testing, where they'll actually change your code and change like greater thans to less thans and change, you know, static strings to other static strings and see, hey, your test should be failing now. Will give you a better, a slightly better indication of your quality of tests, but it's still not completely there, right? Like the only people that can really tell you, are you getting value out of your tests, are you as you continue to write and maintain your software.
Yeah, definitely.
Yeah. I think.
Go ahead.
I think like having a second pair of eyes on the project is actually more valuable than being like, this is the number we need, especially if you're in a larger organization and you have like a bunch of teams. If you tell a junior, these files need to have 100% code coverage, but they're not great at writing tests, they will get it to be 100% code coverage, and you will have trash code that you think is tested. Like, I think it's far better to normalize, like, yes, it should be high, but it should be far better to normalize, hey, I want somebody else to check out my code. You know, even if they're not fully on the project, if you've built a big thing, you know, pull in somebody else from the organization and be like, yo, I just want to walk through this with you. And, you know, because you might have assumptions in your head that since they don't know anything about it, they'll be able to pull up. But if you're just going to go by a raw number, you're just going to shoot yourself in the foot.
Can I tangent on that point a little bit?
Of course.
The reviewing of code, it should be also reviewing of the tests by yourself and other people. And it goes back to that first question, what are mistakes that people make? I think sometimes people don't look at what the test is saying. They might have a test name that doesn't match exactly what it's asserting. Their assertion might fail and not be that useful. Or maybe they've missed a case. Like they tested what happens if there's one item or two items, but not 0 items or a null. And having another person review it might help them, like you step back and you're like, well, how do I test this stuff? Oh, I should check these things. How do they have tests that cover these things? So we should get that code review or a pull request or whatever system people use should include carefully those tests. The test is important enough on their own for documentation design and regression test purposes that it't be checked just about as carefully as the source code.
Yeah, I think that also helps with happy path testing, where you spend all the time, you have 100% test coverage, but you never test or handle errors, which is something that happens a lot with like prototypes and stuff, because, you know, you don't really care about the errors. But if you haven't tested properly, when that prototype becomes production, all of a sudden when, you know, like a card failure happens, you know, you have no idea what the user sees. You have no idea what's actually going to happen in the system. And now you have like a fully unhandled thing. But if you're writing stuff on your own, you know, generally you're writing to specs. And a lot of the time specs aren't like, hey, here's what happens if all of this fails. So having somebody else come in and like, you know, pull you out of the weeds a little bit is often super helpful for that kind of stuff, because, you know, if you're working on something for 3 weeks, you're going to get focused.
Yeah, I think that's something I try to do now on projects, is always at the requirements level, getting those alternative paths so that you know already that you have to test for it, because if not, your feature is incomplete. So we have a lot of questions from people attending. There was one that is about mocking and stubbing. So what are the best practices in determining how much mocking and stubbing to use? I've heard different opinions from experienced engineers. So yeah, any tips?
Yeah, I mean, there's two schools of thought on this, and it kind of affects how you're going to actually work too. I think there's Detroit and London style TDD. Detroit style tends to be what we think of as way more pure TDD, where you write a test, you write a line of code that makes, or you run the test to make sure it fails, you write the line of code that makes the test pass, you write another test that now fails, you modify the original line of code so it covers that, and so on and so forth, and your entire system grows from there. That tends to be usually lighter on the mocking and refactoring because you that kind of shears it at kind of the code smells and necessity spectrum. Like, you start to pull things out when it becomes too onerous to test them, and that is part of your refactoring process. When it becomes too onerous to test what it does, probably in the pulling out of another class, you then mock that next class. London style kind of goes the other direction, where you kind of try to break it down to what you would think the smallest pieces of functionality are and just test those. And then you always kind of just say, do I interact with my little piece correctly? That tends to, I personally tend to go more towards London style of test-driven development, which is strange because I'm from Detroit, but it just tends to be how it goes. I tend to enjoy more mocking because it helps me feel like I'm doing more focused interface designing, though I do find sometimes it goes overboard sometimes. The manager objects tend to be a big pain because they don't really do anything real in and of themselves. They're just there to make sure you're calling things in order. I think the benefit of this is you have very little side effects when changing things. If you change a class, you should only have test failures in that class, not somewhere off to the side. What you kind of lose in that is a little more ad hoc integration testing. You kind of need to be more, when you use more mocks, you need to be, even when you're not interacting with external things like the file system or the database, you need to be a little more kind of conscious about adding integration tests, because it's like, oh, this calculator thing, you know, all of its little pieces are tested, but nobody actually, you know, added and multiplied in the same thing, and somehow the plugging in of those two adder and multiplier components into the calculator manager didn't work correctly because somebody added a null into the constructor or something, and we didn't catch that. So yeah, I don't know if that necessarily answers your question, but yeah, I hate the term best practices, because if it was best practices, everybody should only write software one way. But the good practices are, in my mind, usually focus on only one class and mock everything else out that isn't that class.
I want to go back to the question that involved the word stub as well. And here we're using, I think, mock for everything that's a fake in a system. Like for what Jeff was saying about the interactions with things, you want to mock out those other classes. I would say you might want to have fake versions of things where you might have a fake database connection that will on command, throw an error, or on command, produce the right data. So that in your test, you can choose which one will happen. That's the important part of producing what is generally called test doubles, things that stand in for the real code. Whether your testing library calls them mocks or stubs or fakes or test doubles is irrelevant. They all do slightly different things, but generally you are producing, you are inserting into the code under test things that pretend to be the real thing, but are not, because if they were the real thing, it'd be sort of annoying to have a database connection or a network connection or a medical device connected to your machine, or inserting into a patient. Pretty bad idea. So you need to have fake versions of those, pretend versions. And by having pretend versions, you can easily have one that throws an error on command, or produces the right output on command, or produces lots of output on command. So having that sort of stuff is very important. But to reiterate what Jeff said, and it's something I'm very mock. I love mocks. I do it too much, I think. I'm starting to swing a little back now. You have the danger of forgetting that all the fake stuff that you're creating is in fact fake stuff. And if your fake stuff doesn't exactly match the interface of the real stuff, you can get into some problems. Now, your language might be have static types and would disallow this from happening, but you can still even get away with some weird shit there. Sorry, weird stuff there. And so it's something to keep in mind as you're creating these pretend objects, these pretend functionalities for your testing purposes. Keep in mind that they're pretend, and you need to make sure that they're not getting too far away from the reality, the real interfaces.
Right. That brings up a good point. When I said mock, I did mean, mock is a loaded word for libraries and stuff out there. I did mean, in my mind, if you want to really get into how these things work, you go the artisanal route and you create your own, if you want to get really deep into understanding testing and test libraries and things like that are out there, try to write your own testing framework. That'll get you really deep into the bones of how languages operate and work, because all of these were written in the languages they're testing.
I would also say something very important about using mocks and stubs is that often people will do that and then they'll have a static return value. I think something that is wildly useful is incorporating something into your framework that can generate random values for things. The number of tests that I found out were flaky when somebody is like an O'Donnell because there's an apostrophe in their name, and it breaks all of these other things down the line. But when you're writing the test, you're probably just going to write like Bob or Mr. Foo Bar. It's like, so when you are doing that sort of mocking thing, you do want to include something in it that says like, okay, yes, this is returning a fake value, but I don't want to have a static value for that, unless of course you're testing date time things, in which case return one value, because you don't want that. You don't want that sort of evil.
It is something that I now always look for, like a library, because I won't be able to think of all the different fake cases. So it's something, and it's generally available for every stack that you're working with.
I think that gets into a topic called generative testing, which I don't have much experience with, where you define, say at the functional level, this function takes parameters of these types and should return a value of this type. And generative tests will generate hundreds, thousands, millions, however much you want, random inputs and verify that the outputs are all correct. It goes along with that idea of the mutation testing. But that's like a separate category. It's a different style of testing.
We had an interesting question. I thought that we have 5 minutes left, but maybe we can address it. So it was about testing client-side code. So one of our engineers was saying that the feedback loop was, when testing UI code, the feedback loop was faster, like just writing the code than doing TDD. So what would be recommendations for someone who wants to do TDD for their client-side code but struggles with the practice?
Write it in React.
That does help.
I think writing, plain JavaScript, plain jQuery components, it's a process that we all got very ingrained in for years. But if you're using something like React for the front end, TDD actually becomes a much easier way to write it, and to ensure that you don't have to go back and rewrite it. Personally, when I'm writing React, I write all of my layout tests so I know things exist when I expect them to exist, and then I can write functionality tests and know that it does functions. And then integrating it becomes simple because I know this component operates like this every time. If you're writing, cucumber tests or phantom tests to like just iterate over behavior using like a headless JavaScript driver, I think that's useful, but oftentimes those tests become really, really long. And I know most places I've worked that have that sort of test, those tests wind up cropping up into like tens of minutes when you test the whole site, and people just stop running them, or they start testing to the interface by writing the interface and then changing what those tests are because they get a little too complicated and they take so damn long to run that I think, if you can, you write something small, you write it in a very compact behavior. Like if you're going to write something in jQuery, don't write, hey, I'm grabbing everything off of this. Write a thing that says, I grab these elements, and then test all of the functions inside of that as a module so that when it grabs this thing, it will operate like this. But like, if you're just gonna do testing like, well, I go onto the page and I enter this information and then I click submit, you're gonna wind up with tests that nobody runs.
Sorry. You go, Jeff.
Okay, this might veer off somewhere, but to add to that, or add an extra layer of craziness or insanity to UI testing, there is a library out there called Quixote. I have never worked with this professionally. I'm wondering if the name is a meta commentary on the elusiveness and insanity of trying to test drive UI, but it definitely is something that completely has my imagination captured, because what it allows you to do is, before writing lines of code, enter test specifications based on screen layout, screen width, pixel distance, background colors, and all of these things of where you expect things to show up on a screen. And I don't know if that's like some snapshot testing where it's very unreliable and you will get a lot of flaky tests, or if it's actually good and you can say, I expect my header to have this much distance between the bottom of the font and the start of the next color. But from what it purports to do, you should be able to take a designer's specifications and actually enter it as your test for a component, and that should be irrespective of your implementation. If you do it in CSS, if you somehow decide to do your stuff in tables or flow or whatever, this kind of fulfills the dream of test-driven UI. Now, once again, never actually used it professionally. I think I've played around with it on, personal development time and been fascinated by it, but it's out there. If you're willing to.
The author's name is James Shore. It was developed and shown in his screencast called Let's TDD JavaScript.
Thank you. This is going to conclude our discussion. Thank you very much to the panelists and to everybody who asked questions in the chat. We're going to pass it back to Jen.
Yes, thank you everyone for attending and joining us, hanging out with us on today's event for breaking down TDD. As mentioned in the beginning, I do have just a handful of announcements, so I'm sorry. I'll try to do them in a minute so we can end it right at 10 o'clock, but it is 10 o'clock. So we offer both engineering and product office hours. This is free. Something we find helpful to our community is to be able to help you guys if you're stuck on writing some code or in your project, whether you're a product manager or engineer. If you need help getting past that hurdle, sign up for our free office hours. Next slide. Also, if you liked us and you want to know more about us and our upcoming events, follow us on social media. We are on LinkedIn, Twitter, Facebook. We have a blog on Medium, and we also have a newsletter, which you can sign up from the website. It's not hard to find, but you'll get updates about what we're doing as a company, things going on in the industry, lots of cool stuff. Last but not least, something I mentioned earlier was we are hiring. We're looking for 2 different people, UI UX designer, as well as a senior product manager. So both of these can be found on our website near the bottom of the homepage under Join Us, or you can click on the link. I think, Christine, you're going to add the links in the chat. So you can find any of the links to any of these announcements there. One last thing I did want to mention, we do have an upcoming event in September that will be hosted by our senior product manager, Merzia, and look out for an invite on that if you're interested. Thank you again. That concludes our event for today. I hope everyone enjoyed our panelists. If you have any questions or inquiries, please reach out to us at info@defmethod.com. We look forward to hearing from you soon, and we'll see you next time. Thank you, everyone.